reminds me to call those people now, the facility, to see if they finally fix it.
No, we had something in SSB 170 the other day, kind of like an awards for CalTeach, and it was fine.
Was that early? Because remember, they turned on the AC a certain time.
No, see, it was, when was it? It was like 5:30 to 7:30.
Okay, so then it's fine,
Okay.
right? Because I feel that they turn it on like at 6. Right? Okay. All right. So any questions on the material? For the control of the stomach, that's where you're talking about, by the intestines with the CCK and secretin and all that, you should know that. Yes, because the in-depth portion is coming today and Wednesday. That's where the in-depth portion comes in. But even with that, the exam should not be, I think the hardest exam that you guys had was exam number 2, the endocrinology. I don't think that even with the metabolism portion on it, it is not that complicated. The only thing that I find that it will be a little bit more complicated is the transformation of low density lipoproteins, the LDL, to HDL by the liver. And that's the whole cholesterol myth thing. I think that's the only portion that's biochemically full of details. But besides that, it's fine. Okay? And then from that portion, what you really needed to know, you need to know one portion of digestion, right? Another portion of absorption that we did on the board last time, right? Digestion and absorption, and then from the absorption, if you understand well absorption, the portion that you really needed to get in your head is 2 portions. Number 1, the sugar, we know what's going to happen. The sugar, I'm not focusing on that, right? Because it's going to either be transformed into glycogen or going to be used by the body. Simple and easy. Now, the proteins, you have two pathways you can go. You can use the amino acids as building blocks for enzymes and other proteins that you're going to use in the body, or you can deaminate this thing, right? And you can use it for producing energy, ATP, right? It can be a source of pyruvate, can be a source of alpha-glutarate, or so on and so forth. Now, there's a third portion, because if you eat protein in excess, it will still be stored in the fat. So protein will be deaminated, and the acetyl, the 2 carbons, are going to be linked into a tail, and it will be packed inside of a triglyceride and then be stored in a fat cell, in the lipocyte. So that's the 3 destinations of protein. Now fat, and remember, all this goes directly to the liver, right? Yes? From the small intestine and absorption, protein goes directly to the liver. The liver does all that. Now fat is a different conversation, because fat goes to the lacteal, to the lymphatic system, right? To the superior vena cava, to the heart, to the aorta, to the abdominal aorta, and then to the liver. And once it gets to the liver, it needs to be processed. If it is phospholipids, well, then we're ready to go. We can store that in fat cells. We can use that as a building block for myelin sheaths, right? Or we can use the cholesterol, which is also fat, to produce hormones, vitamin D in the skin. But the triglycerides, well, the triglycerides is a different conversation, because triglycerides comes with the three tails, and you can use that for building energy. Yes, you can use that, and you can store that and then use. But you need to process this triglyceride. You need to feed the cells, the lipocytes, with this triglycerides to store for later. And to do this, to feed the fat cells with triglycerides, you cannot let it continue circulating on the bloodstream in form of kilomicrons. Because remember, that increases the viscosity of the blood, and that's a problem, right? So then it's packed with proteins. It forms little vesicles. LDL, nothing more is a vesicle of fat full with proteins, different kinds of proteins, and cholesterol. So you pack triglycerides, cholesterol, and certain proteins all together. And then you start with a biochemical process of exchange that starts on the liver, where you give it away some fat, and you keep the protein. Until it comes to the point that you gave it away so much fat that now you have less fat density, and it becomes a HDL, a high density lipoprotein. The high refers to the protein side, not the lipo side. So it has more protein than fat, where the LDL, it has more fat than protein. It's a ratio. The cholesterol has nothing to do with it. It has cholesterol inside. You need the cholesterol. Your plasma membrane needs cholesterol. Vitamin D is made of cholesterol. Gazillion hormones are made of cholesterol. But to physicians, to not give this whole explanation, they simplify to a point that they call good cholesterol and bad cholesterol. But cholesterol has nothing to do with it, and that is a huge misconception. That's why it was the whole thing of not eating eggs, and there was a margarine paid for research, margarine company paid for research to prove that butter is bad for you. And then the paper was retracted, but nobody talked about, like the autism paper with vaccines. Paper gets retracted, but the general public doesn't know, because that's not news that sells, right? CNN will burst the whole day about margarine being better than butter, but they will not talk about the paper was retracted, because people will not understand what is that. What's paper being retracted? They don't understand what is that. So then there is this whole misconception about cholesterol, that you cannot eat eggs are bad for you, and blah, 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 blah. However, there is a genetic portion of it, which has nothing to do with the amount that you eat. There is a predisposition like any other disease. If you are, and you're going to understand the formation of plaques, because that's where I'm going to go, if you have autoimmune problems on this specific section, your macrophages that are responsible to swallow, okay, LDL, excess of LDL on the bloodstream, might not do the job. We also have another situation where the epithelial cells, the simple squamous epithelial cells of blood vessels, might not endocytose the macrophage that swallow the LDL. In that case, the macrophage, when it swallows the fat, is called foam cell. It gets stuck on the arteries. And that dead macrophage in there is gonna call for more macrophages to the site, which will die in there too. And this plying of macrophage layers is the plaque that eventually will clog.
Is there a medication or cure or anything to, if you catch that you have that disorder to begin with, to make your blood vessels a little more permeable?
Compliant. I do not know about medication. I know that, well, there is a bunch of lower cholesterol medication. That's what they're trying to do, is to speed up the process between the transformation of LDL to HDL. And I think Lipitor does that. I'll ask Johnny more about it, because he's the one that used to sell that for Pfizer. So he probably knows the entire biochemical mechanism, but I don't know. But what happens is that the artery compliance, what the doctor will do at first, if there's not other congenital heart problems, you will say, well, you need to lower your cholesterol. Because lowering your cholesterol, what they're really doing is telling you lower your triglycerides, lower your animal fat intake. That's what they're really telling you. But this misconception kept on. And think about it. I'm going to give you this idea. You all took physiology right now. So, and I went over that. When I took physiology, nobody explained to me this. In fact, when I took physiology, endocrinology was not taught. They just skipped. This whole cholesterol stuff, they just skipped. Reproduction, also skipped.
What did they teach you then?
Yeah, right? They taught me the kidneys, the urinary system, the heart, the brain, only axial potential, which in fact I knew more than what they were teaching me, because I had just took neuroscience. So if you take physiology and this is not taught for you, or you don't take physiology and you enter medical school assume that you learn this in your undergrad. Or if you have a bachelor in literature, which some people have when they go to medical school, okay? But they did extra organic chemistry, physics, and general chemistry, right? And they enter medical school that way. They get a good MCAT score, they're smart, but they never saw the material. So they graduate from medical school assume that you already know. Then you go into practice as a general physician. You're going to continue repeating this. Right? The whole cholesterol tail. Sorry. So, the cholesterol, what they tell you to do is to work out if you're young enough, right? And you don't have any other heart problems. Why is that? Because by working out, the heart is a muscle, and you exercise the heart. Are we on time on 9:30? It's physio, but you can sit down and listen to physiology. So, what happens, when you work out, the heart is a muscle, so you're going to exercise the heart. That's what you do. And by exercising the heart, you increase in cardiac output. And if you increase in cardiac output, you're also increasing blood vessel compliance. Remember that? And then by increasing blood vessel compliance, your blood vessels are capable to withstand more stretching. So once the plaque formation will happen, you have more blood pushing through it, and it might wash out those macrophages that are stuck there. And then if you combine that with lowering your intake of triglycerides, you lower the probability of them getting stuck there. So that's why when people have high cholesterol, high LDL amount, which is really high triglycerides, when they have this high LDL, they say, okay, stop eating animal fat, so you lower your level of LDL, so you can lower your probability of this thing to get stuck inside of macrophages on your arteries. That's really what they're telling you. But
So that's what's lowering your risk of heart attack.
that's what lowering your risk of heart attack. However, some people, as you know, eat very well, right? They do exercise. Maybe they don't have a congenital problem in the heart, a valve that's not closing, fibrillation of some sort. They don't have nothing of that, but they have very high LDL level. There is those cases, right? Person is young, doing everything they can, but they still have LDL. Why is that? They might be missing an enzyme in the liver that helps to transform the LDL into HDL. So no matter what they do, all the triglyceride that they eat, it stays as LDL. Or maybe they have a very prominent immune disorder where the macrophages are not going to be absorbed by the epithelial cells of the arteries. It's going to be stuck there no matter what, because the epithelial cells maybe miss a receptor that's capable of binding to the macrophage and perform the receptor-mediated endocytosis. So it will build up no matter what. You can exercise as much as you want. But the physician, obviously, first of all, we don't know exactly which kind of receptors. And the physician, of course, will not know what kind of thing you have. So it will try a prophylactic measure to say, okay, exercise and lower your cholesterol. If it's a good physician that will also do some background check to see if you have any congenital thing on the heart, because if you do, if you have a fibrillation of some sort, or if you have a valve that's not closing all the way, you should not exercise. Remember that? Because if you do, you will have a heart attack. So very, very important to think about the background information as well. It's not a formula fits all. Send people to exercise, no matter what. And then there is like the measures that needs to be done now. If there is high blood pressure, because maybe there's already build up on the arteries, you must take a medication to lower the blood pressure, right? Until the problem is further investigated and further fixed. The first thing to be done is a blood pressure medication, not an exercise. Because you send someone to exercise, the person, if has another problem, might pass away.
I have an unrelated question.
Mm-hmm.
About, when that just reminded me of our old manuscript 1. So I did the implications, and I said that if you exercise regularly, then your body acclimatizes. And so for this, and they said, okay, you didn't measure for that. You only did an acute study of 2 hours. You shouldn't. So for this lab, we only did an acute study of 2 hours.
Yeah.
And so we did not measure for any renal function, renal damage, or anything. So what could be a possible implication?
So you measure only for the heart?
Well, we measured only the kidney function, right?
Oh, the kidney function, the kidney lab, the renal lab.
The renal lab.
Uh-huh. So you measure only for the kidney function, and you were asking for the implication on the heart?
No, because I got doc points on the implications for the heart, I don't want to do the same mistake for the renal lab.
Oh, got it.
So that's why we talked about sodium excretion, and we talked about the urine volume.
Mm-hmm.
So how does that, what implications can we say? Okay, so higher sodium in intake leads to less urine output, but how does that help the general public? I'm just having a hard time figuring out, like, trying to say implications, but not generalizing it so much because we did an acute study. I don't want to lose too many points.
Gotcha. So you're trying, because the implication sections is to you to clarify something for the general public.
Right. Why
Yeah.
did we do this lab?
Yeah.
Right, what's
So
important?
high sodium intake, it will lead to high blood pressure, right? High sodium intake will lead to high blood pressure. If that, and you can put it like this, if that is not a constant intake, the kidney will filter it eventually. But if it is a constant intake, and if that individual has other background problems, such as diabetes or any other heart problems, then that can lead to a chronic hypertension. Put those if.
Okay. So we say that this is an acute study, so we saw that the kidneys did filter most of the sodium, or did filter sodium out.
Mm-hmm.
But if it was a constant,
If it is a constant
high sodium diet,
high sodium intake, it can lead to hypertension, chronic hypertension, if the patient has high sodium intake plus other pre-existing conditions, such as diabetes or such as heart problems. Yes? For example, I eat a lot of sodium. I know I do. My sodium is super high. But people in my family never die of heart problems. They live until 98 with the heart of a 12-year-old. True. Everybody with my blood pressure, even me eating as much sodium as I do, my blood pressure never goes above 120. I have very low blood pressure. Plus, no diabetes at all. I don't like sugar, so I don't eat sugar. No diabetes at all in my family. So I can get away with eating sodium, even though it's not good for me. I can get away with that without having heart problems.
do you compensate with water?
No, I compensate with coffee.
I probably
So I'm
should give you an idea
dehydrated
of
with
lactose
high
medications.
sodium in my bloodstream. And then no wonder I have nightmares at night, and I wonder why the nightmares are coming from.
I wonder.
Yeah. It's like the butter thing, right? I just ate 9,000 calories of butter. I don't know how I am not hungry until 12. I know. Yeah. Okay. So put those if there, Georgina, so you can protect yourself,
Right.
right? Because you cannot say for sure that it will cause a high blood pressure because it was they can say it's a one-time deal.
Right, they said every time you make an implication or say, okay, so you have there was a lot of sodium in your urine because you took
A lot of-
you can't say that. You have to say, so it's suggested that you have higher concentration because you drank too much. So everything
Sure.
is suggested.
It's suggested.
So I paid attention to that, but it's just that I didn't know how to not generalize the experiment and the implications.
Mm-hmm. And you put those if. And that's how a physician would refer to things, right? Because he cannot say that you have high sodium in your urine because you ate a lot of sodium. Maybe you didn't.
Right.
Maybe your channels are with a problem. Maybe your sodium channels in your kidney, right? Because you excrete sodium out to bring potassium in. That's what you do. Maybe maybe they're with a problem. Maybe it's not your sodium at all.
Maybe you just have high glucose.
Mhm.
You're diabetic.
Maybe you have got, yes, exactly, maybe you're diabetic. Exactly. Mm-hmm. All right. Any other questions? No? Okay. I'll post the paper post lecture. I will see. Maybe I can get